Here we are going to represent an important note on limits. Limit x approaches to a f of x by g of x. The given function in p by q form means rational form. The limit can be applied to the numerator and a denominator like this. If you apply x is equals to a in the given function f of x, then it is f of a by and to the g of a. Here, if g of a equals to 0, that is denominator value is 0. Along with, we have two cases for numerator. What are the two cases for numerator? Is suppose the numerator value is f of a. Here f of a, case 1 is if f of a not equals to 0. Case 2 is f of a is equals to 0. So along with the denominator g of a equals to 0, we have two cases, f of a not equals to 0 and f of a equals to 0. For case 1, f of a not equals to 0 and g of a is equals to 0. It is of the form not equals to a by 0 form. So any non-zero in numerator by 0 in denominator is infinity. From case 2, f of a equals to 0 along with g of a equals to 0, it is of the form 0 by 0 form. For case 1, there is no problem, means infinity, it is not defined. For case 2, 0 by 0 form is there. Then the given problem, limit x approaches to a f of a x by g of x is of the form 0 by 0 form after applying x is equals to a in the given function. In this case, we split numerator f of x and g of x into factors or transform the given problem into other variables also. That is, suppose if we split f of x into factors, suppose f of x can be factors transformed into factors into x minus a whole power k f1 of x, and g of x can be transformed into factors x minus a whole power l into g1 of x. Then the given problem limit x approaches to a f of x by g of x can be written as limit x approaches to a x minus a whole power k into f1 of x by x minus a whole power l into g1 of x. Now here x minus a both are common factors for numerator and denominator. Here two cases arise. Here k greater than l, then we have apply x power m minus n formula. So x power m by x power n, you know, x power m minus n. So like that, x minus a power k minus l into f1 of x by g1 of x. Now we apply x is equals to a to this. We have a minus a power k minus l into f1 of a by g1 of a. So a minus a means 0 into f1 of a by g1 of a. 0 into anything is 0. So if k greater than l, the limit value is 0. The another case is also there. If k less than l, then the given limit, this limit, then the given this limit, the numerator x minus a whole power k can be taken into the denominator, which is of the form limit x approaches to a g1 of a by x minus a power l minus k into f1 of g1 of x f1 of x. Means by using a power m by a power n equals to, if n greater than m, we have 1 by a power n minus m. Now we apply x is equals to a. We have 0 in denominator. So anything by 0 is equals to infinity. Coming to some standard formulas and limits. First standard formula is on trigonometric functions. Limit x approaches to a sin x by x, that is equals to 1. Here not a, 0. Limit x approaches to 0, sin x by x is equals to 1. Limit x approaches to 0, 1 minus cos x by x is equals to 0. Third one is limit x approaches to 0, tan x by x is equals to 1. And fourth one is limit x approaches to a, x power n minus a power n by x minus a is equals to n into a power n minus 1. Fifth one is limit x approaches to a, x power n minus a power n by x power m minus a power m is equals to, so like this, n by m a power n minus m. And sixth standard formula on limits is limit x approaches to 0, e power x minus 1 by x is equals to 1. This is on exponential function. The seventh standard form on limits is on logarithms. Limit x approaches to 0, log of 1 plus x by x. 1 plus x by x is equals to 1 plus x by x is equals to 1 plus x by x is 1. And eighth one is limit x approaches to 0, a power x minus 1 by x is equals to log a. Okay, these are the standard limits on trigonometric functions, exponential functions, logarithmic functions.